Okay, we're going to do some complex fractions. Basically, a complex fraction is a fraction itself that has fractions in the numerator or the denominator, or a fraction that has some variables with negative exponents in it. So when you simplify these, I find it best to work with the top of the fraction and simplify the top, simplify the bottom, and then deal with the complex fraction again. So the common denominator, if I were to do the top, would be 8. So I could multiply this by 2 and this by 2. At this point, I get 6 over 8 minus 1 over 8. So I get 5 over 8 for the top. Now I'm going to do the bottom. 2 plus 1/12. Let's make that 2 over 1. Common denominator 12. So multiply by 12 over 12. So now I get 24 over 12 plus 1 over 12. 25 over 12. Now I have a complex fraction, 5/8 over 25 over 12. Basically, I can now write this as a division problem. It means 5/8 divided by 25/12. And division of fractions has another step. I do 5/8 times 12 over 25. At this point, I can reduce. I know 4 goes into 8 twice. 4 goes into 12 3 times. I know 5 goes into 5 once. 5 goes into 25 5 times. I can reduce what's left. 1 times 3 is 3. And 2 times 5 is 10. So I get 3 over 10 as my fraction. So there's one complex fraction. Let's try another one. This one's a little trickier. All right? So let's see what happens when we work this one out. I'll put another piece under here. All right. So, first of all, make the top 2 fractions. Make the bottom all fractions. Now, on the top, I need a common denominator. Common denominator of 1 and z would be z, so multiply the first fraction by z over z. So then I get z squared over z minus 1 over z. Let's do the same thing for the bottom. Multiply this one by z over z. So now I get z over z minus 1 over z. All right, simplify the top one more step. This becomes z squared minus 1 all over z. Then I have my fraction bar, my big fraction bar. Let's make that one fraction. Z minus 1 over z. All right, do you know what to do next? Well, I need to take the first fraction, z squared minus 1 over z, write divided by z minus 1 over z here. That divided by symbol, change to multiply. You know what happens next? Z over z minus 1. Now, I like to keep parentheses around fractions whenever they have plus and minus signs in them. Now, before I write this next fraction, z on the bottom, not a problem. But that factors. Do you remember what that factors to? Sure you do. Difference of 2 squares. Z minus 1, z plus 1. Okay, so I have the fraction settled a little bit. Now I can reduce. Do you see anything that can reduce? Oh yeah, z minus 1. What else? Z. So, left on top, z plus 1. Left on the bottom, 1s. 1 times 1 is 1. So, I could just write this as z plus 1. Final answer. So, let's try another one. Okay, this one has negative exponents in it. So you have to be careful when you see negative exponents. A to the negative 1, this little part here, really means 1 over a. So I have 1 over a minus 1 over x all over 1 over a squared minus 1 over x squared. Now that I've dealt with the negative exponents, I can work the fraction. I need a common denominator for the top. If I want to add 1 over a and 1 over x, I need them to have the same denominator. I can do that by multiplying. I can multiply this one by x over x and this one by a. So now on the top, let's put our big fraction bar here. On the top I have 1x minus 1a, or x minus a all over ax. And remember, if there's minus or plus signs, I like parentheses. All right, let's do the bottom. If I want to combine these two fractions, I need a common denominator. It's going to have to be what? Do you know? A squared, x squared. So this guy needs an x squared. Multiply it in. This guy needs an a squared. So the bottom fraction, now I can write it as one fraction, x squared, a squared. What's the top? Hope you see x squared minus a squared. And again, if you have a plus or minus sign, make sure you put a grouping symbol there. Now at this point, what do I have to do? Well, let's write it as a division problem. So I have the top, which is the first fraction, x minus a, all over ax. Then I put divided by x squared minus a squared over x squared a squared. Again, parentheses whenever you have plus or minus signs. Change from the divided by x minus a over ax times x squared a squared over, oh boy, do you notice that that factors? Oh, I forgot my parentheses here. So factor it before you rewrite it. It's a difference of two squares, x minus a, x plus a. All right, at this point we can reduce x minus a and x minus a. How about an a with one a there, x with one x there. So final answer, x a over x plus a. Put a grouping symbol. Can I reduce that xa with this xa? I hope you said no, because they are not the same. If that was x plus a over x plus a, I could reduce it and say that it's 1.